So I want to move ahead at looking at the clock frequency of the 555 on the board here and setting it. So what frequency do we need to set it to? So again, I want to thank Jonathan or Glitch for the help on this. So if we take 9600 baud and we times it by 16, we get a 15,360 cycles per second, so 153.6 kilohertz. Did I say that right? Yes, 153.6 kilohertz. I said that slightly wrong. Anyhow, the ASIC up here will get set to divide by 16 mode, which means to output 9600 baud, it needs 16 times that coming in. And that's why I did the math I did. So we want 9600 baud out. We multiply it by 16 because this chip here does a divide by 16, and that says we need a frequency coming in of 153.6 kilohertz. So that value is going to be important. So hopefully that showed up on camera. Let me get this up here where maybe it'll show up a little bit better. 9600 baud times 16, 153,600 or 153.6 K. So very appropriate calculator for the time frame. Nice calculator. We've looked at it in a different video. So how are we going to set this? Well, I'm going to use a frequency counter to set this. And I'm going to use a frequency counter that again would be from the era where this would have actually been being built. And that is this Simpson 7026 Universal Electronic Counter. It's a Nixie tube device. It's one of my favorite pieces of test gear here in the lab. I just love this thing. It's just such a neat tool. It is old enough that it doesn't use an IEC line cord. Instead, it uses a line cord like this, with, of course, that pin there being earth ground and the line and neutral coming in. So these line cords are getting harder and harder to find. If in your travels you find a line cords like this someplace, grab them, because like I said, they're getting harder and harder to find. And for these really old test instruments, they are important. So let's go ahead and plug this in. Let me get some AC power on the other side here. It's plugged in already. And let's give this thing a play, and hopefully I can get it in camera shot here. I didn't plan well ahead of time for this. I need to get it up off that line cord. Do I have something I can do that with here? Will it sit up on this roll of tape? It might. It's not meant to be set up this way. And it might not sit on there. Okay, I think it's going to sit there. Let's get it centered up under the camera. Let me take a peek at the camera and make sure you guys can see the front on this. It looks like you can. You bring the power up. I need to move it slightly where I can see. Okay. So there it is. Right now I have it in self-test down here. Self-test should show us 1,000 hertz. 1,000 hertz, 100 kilohertz. Boy, kilohertz. Yeah, 100 kilohertz. What am I saying? Hertz. So there's 100 kilohertz right there. It's spot on. Kilohertz over here, and the gate is triggering fairly quick here. That's more than once a second. Here's a gate of once a second. So we're missing the flash there, but it's gating once a second. But as we come across the ranges, this should stay 100 and something. So there it is measuring hertz. So there's 100,000 hertz. Let's see, it hurts here. I'm trying to remember the difference between some of these, but we're going to be measuring up here in probably right here. Kilohertz per second, maybe over here. Anyhow, this is the device I want to use to do this, and of course we can adjust it here. Well, we can't currently because it's in self-test, but we can count. We can measure the frequency of something. We're out of self-test now, so it should be very close to 0. We can look at the period, we can look at the ratio, etc. I mean, it's a very capable little instrument. So let me get a lead here to attach to it. Oh shoot, I just dropped the calibration screwdriver. I will need to dig that back up. I'm going to set the scope probe to ×1 because I'm going to use a scope probe here. So 5 hertz to 50 megahertz in, we're going to be looking at input A. Scope probe typically works just fine for this. Let me try to sit this up someplace where it's still on camera, where you can see it. I need to bring 5 volts out onto the board here. And we did this before we did our initial power up. I've got cables on top of cables here. Everything is of course buried under something else, because there's too much stuff on the bench. So let's see, I want supply 3. It is set to just over 5 volts. We have ground here. Is that correct? Well, I actually drew a negative, right? Yes, negative here, positive here. We should be able to take this probe and reference it to a negative, and I need to look at the schematic quick, know which pins I'm looking at. So we are looking at pin 8 as the actual driver off the 7404 down here. So where can I get on pin 8 at? It goes to pin 3 and 4 up here on this socket. So can I get a lead in there and get a connection to pin 3 or 4? I don't want to use too large a diameter lead. If I can get a grip on there. So that should get us the clock frequency at the ACIA. Let's go ahead and turn the power supply on. And it's measuring something. We did see a change. There it is. Okay, I've got it running way too. So we need to tweak that up to, what was it, 15? Hopefully we can tweak it up that high. What did we say it was? Well, we can bring back the calculator and figure it out again. 9600 times, divided by 16, or in this case times 16. 1536, so 153.6. So we should get this to 153600 if we can. So let's see if we can tweak it to there. As always, I didn't plan ahead well, and the tool I need is not here. $150, 1, 2, 153. You can see it dancing around here. Okay, I've got my hand off the board now. And we'll keep adjusting upward and see if we can get 153.6. Getting close. Oh, now it's over. If I roll the sensitivity all the way down, it should quit counting, and it did. So you can see here that the gate time matters, because it sets how quickly it's counting. So that's a little bit high. 153.6 is what we're after. So we've got a faster gate time now. You can see that me simply touching the potentiometer with the screwdriver makes a difference. $153.7. I should be using a non-metallic screwdriver. Ooh. I think that is super close. Let's get a longer integration time. 153.59 or 58. We'll see if we can bring it up just a tad. $5.7. Still 5.7, 153.57. Honestly, that's probably close enough. Why do I appear to be going the wrong way? $153,644, a little tiny bit high. I should find a non-metal tool here. I can't get into the slot suddenly on the pot. Let it stabilize here. 153.65. Still at 153.65. Can't get the screwdriver to engage. I'm making very tiny little adjustments here, trying to get it closer. I'm glad that the 153.6 is somewhat centered here, so I'm not making any difference when I move it. Okay, it came down a little. Getting closer. Yeah, I'm being incredibly anal here, trying to get this as close to spot on as I can. Now we're under again. Wow, we're under by 40 hertz, or we're over by, well, we're under by 30 hertz here. I just can't seem to hit the center spot there. You can see that when I bring the screwdriver in, it definitely changes it. I should probably get a non-metallic tool here. Let me grab one. I know I have some back here. See if we can make this a little easier on ourselves. They just don't happen to be sitting here on the bench. So when the one I probably want is gone missing from here, this guy here might work. No, I'm making it worse here. Ooh, that's really close. Okay, that's probably as close as we're going to get. I would say that is as close as we're going to get. And again, we're at 153. We're looking for 153600, and we're at 153606, 607. It's counting for a full second to get to that number, so it should be pretty accurate. How cool is that? How cool is that to be using an old school Unitrix 800K calculator, a Nixie Tube Simpson 7026 universal counter. This has been a really good instrument. Really happy with it. This came from Boeing Surplus back in the day, and it includes the owner's manual, which I can see from here, but I can't reach. Had the owner's manual with it, and it's just been an excellent instrument for the age it is. I am really happy with that. So we've tweaked in the frequency here to get 9600 baud out of that UART. So again, what we're doing here is we're setting the frequency the 555 is running at. We want it set at 16 times the baud rate we want. And again, the target baud rate is 9600. And if we times that by 16, we get error because I obviously did something wrong. Clear 9600 times 16. 90. Clear. I can't see the. Okay, 9600 times 16. Didn't see the times. 9600 times 16. 153600. 153584. So it's drifting up and down a little bit, but that's okay. Pretty sweet. So I think we'll wrap this one up here. That's about as good as we're going to get this for now. We'll keep moving forward on this, and I will see you in a future video.